Hello and welcome to section 12.2 on solving quadratic equations graphically. So what we're going to be doing today is really just graphing quadratic equations just like you did in the last section, and then finding what the solutions to that equation would be. So we already know how to graph them. What we're going to be doing is using the knowledge to solve the equations. That's kind of what I just said right there. Down here it says ax squared plus bx plus c equals 0 means for what x values do y equals 0 in the function y equals ax squared plus bx plus c. And so really what we're doing is we're looking for where y equals 0. And what that technically is where the graph crosses the x-axis. All right, and that's what we're going to be looking for today. So let's read this little box real quick. Solving quadratic equations using graphs. The solution of a quadratic equation in one variable can be solved or checked graphically with the following steps. Step 1 would be to write the equation in that form. Okay, with instead of y equals or f of x equals, you have 0 equals. That's not as big of a step. I commonly don't do it. I just do the step 2 and can't even make a step from there, is to just graph that, right? And then you're looking for, down here it says the x-intercepts. Okay, and those are called the roots. We think of roots as being x-intercepts, but that's also the solution to that equation, okay? What they're really looking for you to do is if there's anything but 0 over here, that you would move that over first. Okay, we may have a couple that are like that, but it's not much to worry about. Okay, so here we go. We're going to start off with this problem right here. And it says, remember to find the vertex as negative b over 2a, and then you plug in negative b over 2a and use it to make a table of values. So let's start off with that. I'm going to grab a calculator, and here we go. So I'm going to just write it out real quick. So negative b over 2a is negative 1 over 2 times 1, which is just negative 1/2. So that's the x-coordinate of the vertex, and that's a negative. So negative 1/2 is the x-coordinate. We're going to go ahead and plug that in. So if you remember how to use the calculator, I'm going to look for fractions here. Oh, so I'll go negative 1/2. Having a hard time with the calculator. It's okay. Plus 1/2 minus 6. Is that right? So negative 1/2 squared. Oh, there's a mess up. Okay, there we go. So I get negative 6 1/4. Okay, make sure you put it in right. It always helps. All right, so negative 6 1/4 is going to be our vertex. So let's see, we have negative 1/2. And I'm going to put my axis of symmetry here. And make sure to stay on the line. So I know it's on that dotted line, and it's at negative 6 1/4. That's going to be right about there. Okay. Every one of those lines horizontally is a point, so I'm saying it's right there. But as we remember, that's not as big of a deal as figuring out the other points to use. So I'm not going to use 0. That's really close to my vertex. So I'm going to use 1, and I'm going to use 2. And then I'm going to use, on the other side, negative 2 and negative 3. And I just picked those numbers at random, and I'll talk about a little easier strategy here in a second. Let's go ahead and plug those in. So I don't need these fractions in here, so I can get rid of those. So I'm going to start with a negative 3. negative 3. So that's going to be 0. Use my negative 2. That's going to be a negative 4. And since we're at a fractional vertex, I'm going to go ahead and use my other points. It's pretty tough to mirror the graph when you have fractional coordinates. So at 1 it's negative 4, and at 2, okay, we just so happen to pick numbers that were even distances away from the vertex. Okay, let's go ahead and plot those points, and then we will graph our line. So at 1, let's start over here. At negative 3, it's 0. At negative 2, it's negative 4. At 1, it's negative 4. And at 2, it's 0. And remember, I'm trying to connect those points with a smooth curve. And I just expect that your graph shows effort to, number 1, hit the points, and 2, to be a smooth curve. So something like that would do. Okay, it does say even sketch the graph in the directions up there. So what we're looking for here is we're looking for where this graph crosses the x-axis. Well, we kind of got lucky in the fact that the points that we picked actually equaled 0. Okay, that doesn't always happen. And, a lot of times, especially in the real world, you're not going to have it be at even number, at whole number answers. But when we can, that's what we got. So my solutions here, we're going to get this negative 3 and a positive 2. So we just say x equals negative 3 and x equals 2, because that's where it equaled 0. And that's technically what we're looking for, but it also comes from these two points that cross the x-axis. Okay, let's turn the page and look at the next couple. So we have some examples here, and this is a little more what the problems are going to look like. Rarely do I lay everything out for you and make it really easy for you. I always try to make things difficult, of course, but still doable. Okay, let's look at this first one. And so we're going to have negative b over 2a. Say x equals negative b over 2a. And so we have negative 6 over 2 times 1. And negative 6 or positive 6 over 2 is just going to be 3. So now I want to make a table of values. Since I'm not dealing with a fractional vertex, I'm going to go ahead and start with that and just plug in one side and use the axis of symmetry to help me out. So we have x and y. Let's start at 3. And maybe we just go 4, 5, and 6. Okay, so I'm going to get my dotted line at 3, and that's kind of tough here because of the scale of the graph. Every square is worth 2 units. So I need to find out where my vertex is. I'm going to go ahead and plug it into a calculator. So we're going to have 3 squared minus 6 times 3 plus 5. So we're starting at negative 4. So negative 4, and I can put a point right there. Okay, let's plug in 4 and see what we get. So 4, 4. Negative 3. So at 4 it's negative 3. That's going to be about there. Let's try 5. Hey, at 5 it's 0. Oops, sorry, let me put that one in. At 5 it's 0. That's probably what we're looking for, but let's go ahead and finish this out just to make sure that it follows the parabola shape. Yeah, at 6 we get 5. So at 5 it's 0, and at 6 it's way up here at 5. Okay, and I'm just going to use my mirror image and bring that one over, bring that one over, and bring that one over. and try to get a smooth curve here. It looks pretty steep with this scale on the graph. And I missed that. So just make your graph a little thicker. And again, that's just showing effort. If you fail once, you can erase it if you want to. Obviously, I can't, but try to make it look as good as you can. So let's see, what are the solutions? It's right here and right here. So this one we know is 5. 5 is 2 units away from 3. So what's this one? 3 minus 2, which is 1. So x equals 5 and x equals 1. If you weren't sure about the second one, you could go ahead and plug your guess into the calculator and see if it equaled 0. And if not, you might just have to change it a little bit to figure out what it actually is. Let's look at the next one. So x equals negative b over 2a. So that's going to be a negative 3 over 2 times 1. Oh, this looks like it'll be fun. 3 over 2. Goody. So let's go ahead and try to figure out where 3 over 2 would be. Halfway here would be 1. So I need 3/4 of the way through this square to give me my axis of symmetry. And again, remember that yes, we're graphing, but we're also using algebra to back up our graph. So it can be a little bit off. But the closer it is, the better you feel about what you think it is. So let's see here. Let's start with the vertex. 3 over 2. And we'll plug that in. I'm going to put it in as a fraction. So I have to insert that, and that's kind of a pain, but it may be quicker just to redo that problem. But that's what we get. So I get negative, wait a minute. That's the wrong problem. So we have x squared minus 3x, and then that'll be a minus 4 on the end. There we go. So we get negative 6 1/4. All right, so we got to take a guess at where that's at. Probably just below the 6. Okay. And now I'm going to go ahead and plug in numbers to the right of this and see what we think we get. I'm going to probably start with, I don't really want to do 2. I could do 3. So let's plug in 3 and 4. And that ought to give us a pretty good look at what we're doing. Oh, I wanted that. So let me get rid of these fractions. Sorry, not 4. I'm starting with 3. I did it again. There we go. So at 3, it's negative 4. So at 3, it's negative 4. And this will be a really hard one to mirror over. So I'm just going to plug in a couple other numbers once I get this half of the graph drawn and try to figure out the other half using just a different set of numbers. Since I already have it in my calculator, it's pretty easy to do that. Let's plug in 4 first. And at 4, it's 0. Okay, well, that's good. So at 4, it's 0. That's what we're looking for. I know that'll be one of my answers. So I know the graph kind of comes up here. Probably looks something like that. Now I have to figure out the other side. I'm going to go ahead and plug in, I think I'll plug in 0 and, I don't know, maybe negative 1. So I'm just going to continue the graph over here. Plug in 0 and negative 1. So let's plug in 0 first. Okay, so for 0 we get negative 4. Just so happened that that was the same distance away from the vertex as 3. So at 0 it's negative 4. And now we can try negative 1. And so the idea here is that I'm not quite to 0, but I know the graph will keep getting bigger. So I know it's either going to be, it's going to be something negative. Negative 1's a pretty good guess. Maybe something, maybe like -1/2 would even be the answer, but let's go and try -1. And there we go. -1 gives us 0. So at -1, it's 0. And we just do our best on the graph. And apart from it being kind of shaky, doesn't look too bad. All right. But the idea here is that we have our answers there and there. That one's -1. That one is 4. So solutions, x equals -1 and x equals 4. So what I want you to do right now is go ahead and pause the video and try the last two. Okay, pause it and go. Okay, welcome back. Hopefully you had a chance to get those completed. And let's go ahead and see how you did. So I kind of gave you a tough one here for the first one because we actually have an a value. And our a value is -2. Let's see how that works out for us. X equals -b over 2a. So that's a -4 over 2 times -2, which is -4 over 4. I'm sorry, -4 over -4, which is 1. So it wasn't that bad, other than the fact that this you could change the scale on your graph if you wanted to and make every grid line worth 1, but I'm going to stick with it and just keep going here. So I know that that's my axis of symmetry, and since I'm at whole number answers, I'm going to use my axis of symmetry and just flip them over that line. Let's start off by plugging in 1, and make sure you change your equation on your calculator. I'm probably going to zoom that out a little bit. Makes it easier to see. So we got -2 times 1 squared plus 4 times 1 plus 6. And so for that we get 8. I'm going to keep going in the positive direction. I guess I can plot that point first. So at 1 it's 8. And so let's go with 2 and 3. Make it easy. Let's see how that works out for us. So we'll plug in 2. So at 2 it's 6. So at 2 it's 6. Let's see what we get at 3. 3 and 3. Okay, at 3 we get 0. So that's good. That's what we were looking for. Again, I just keep going one by one until I get to that crossing the x-intercept line, get to that point. Very steep graph. Almost straight down, but it'll never be exactly straight down. It'll keep growing and growing a little bit. Let's go ahead and flip these numbers over. So it's 1 unit away. Go 1 unit away, or half a square. Go a full square, and then a full square. And that puts me right there. So then we just graph it down here. Again, very steep, but never coming back in. It'll never come back in, or it won't even ever level out and just go straight down. It looks straight down, but it's just really close. So the answers we should get are 3 and -1. Make sure you note that that is an and. Okay, both of those are solutions. It's not an or. All right, last one. Hopefully this one, well, hopefully it didn't trick you too much. I wasn't trying to. I was trying to give you an easy one. Let's see what it looks like. If you remember anything, that's kind of a difference of squares right there. And we've used that in the past. But let's go ahead and see what we have. This is the same thing as saying x squared. Give me 1 second. People don't realize I'm doing videos. They try to call me. So it's x squared plus 0x minus 9. Okay, you can always rewrite it like that so that you have your b term. So if x equals -b over 2a, we get x equals -0 over 2 times 1. Well, 0 divided by anything is 0. Okay, so my vertex is going to be on this y-axis. So in this case, the y-axis is the axis of symmetry. That's kind of cool. Let's see what happens. Let's plug in 0, and let's go 1 and 2. So 0, 1, and 2. So let me get this in here. We're going to go 0 squared minus 9. Tough one, huh? Negative 9. I saw that coming. So at 0, it's negative 9. What about at 1? Again, this is probably one that you could do in your head, because 1 minus 9 is negative 8. So at 1, it's negative 8. And I'm going to go ahead and plot the other side as well. At negative 1, it would be negative 8. And if we plug in 2, that's 4 minus 9, which is negative 5. So at 2, it's negative 5. That's right there. And at negative 2, it'd be negative 5. So I'm not there yet. What do I need to do? Well, I'll keep going. All right. So we're going to plug in a 3. Any guesses what this is going to give us? 3 times 3 is 9. Minus 9 is 0. So there we go. That's what we were looking for. At 3, it's 0. And at negative 3, it's 0. So we give the graph a good effort. That side's kind of, I don't know about that. Oh well, we got our answers. X equals 3 and x equals negative 3. And that's what we have. So from here, make sure you guys know how to use your calculator, whether you're using a phone or whatever it may be. I would definitely suggest one just like this, or even better. It definitely helps you out. Okay, with being able to go up into the next or the last equation and just edit it. That makes life a lot easier. So good luck on the practice application and mastery challenge. We'll see you guys later. All right, so we're looking at some great plays in baseball, and we saw some web gems. For this section, we're going to be looking at some amazing throwouts. So, somebody throwing the ball to the plate where the offensive player is running to, and there's some pretty amazing plays. Check them out.
He rips that one down the left field line. Cespedes on the move. He's not going to get it. And it rolls off the side wall, and they're going to wave home Kendrick. The throw to the plate is there. Oh, my goodness. They got him. Are you kidding me?
It's a 3-1. Ground ball to Pedroia. Nice stop. The flip out. Got them both. Even drew 2 out.
That's why you like to see a guy run on 3-1, because you're going to get a pitch to hit.
Little flare, broken bat. What a play by Goins! That'll do it!
A great evening.
Play right there by Manny Machado. Great reaction. Super first step, and he dives. His glove position is perfectly.
Great play. Oh, what an out at second base. That is unbelievable. What a tremendous play. Look at the look. The baseman to be able to call a runner off. Oh, look at this. Look at that.
Hello
Johnny
there.
Belliard on the ball deflected by the pitcher. Get the replay machine ready, boys. I got to see that one again.
And I tell you, they have the defensive practices out here twice a week. They do not practice this one. This is instinct, and you owe yourself a smile. Up.
Gordon with a diving stance. There's one, there's 2. Oh, what a double play. Gordon with a miracle flip to Turner, and then Turner turns the double play.
The 3-2 pitch. Hit high and deep to right. Back goes Guillen, still going back. At the wall, it's off his glove. There goes Napier out second, head for third. Look at that throw for right. Wow!
That's into right field. That's a can of corn. Bo Jackson is there. As here's a throw. Gallego tagging it. Bo gets it. What a throw by Bo Jackson. Standing flat-footed.
How about that smile? Yeah, he was flat-footed on his heels, and look at this throw. All the way, good catch and tag right here by Robin on the short hop, and he got him.
Hit toward the hole. Jeter backhands from the outfield grass.
Snagged by Lester. And he'll throw the glove. And Rizzo dropped his glove so he could catch Lester's glove.